Hi, this is Mike Lavelle. In this recording, we're going to take a look at how we can use energy data for understanding better how buildings are operating. Our first building we're going to use today is the Audubon Center of North Woods. And this one is interesting because it has a number of photocells that are photovoltaic units that are mounted out in the main facility lawn. You can see the three large panels there. Let me close that off. And I've already pulled up some of the information regarding that. Here's the Audubon dormitory building, and the photovoltaics are connected to that. Notice that we're starting with about 10 kW. It drops down, as you might expect, and then about noon, the power requirements drop way down. That's an indication that the photovoltaics are feeding the power circuits for the building itself. The outside air temperature started off at 70, went up to 87 for the day. An interesting consolidated chart, not much activity for the dormitory building. Now, if we take a look at some of the other real-time data, we can see things such as this is the building loop supply temperature, which is being supplied by a water source, ground source heat pump. So throughout the heating period, we're running from about 103 to about 113, consistent 10-degree difference. We then drop down as they transitioned over to cooling cycle, and the temperature being delivered to the building loop was closer to about 48 to about 58. So this water temperature was being utilized by the fan coils inside the building. Notice that we've had some interruptions here. We had a power failure in which the compressors took off and did their thing, if you will, and it didn't seem to be a big problem here. We also had a power failure here, and the temperature actually went up, and they were hit by lightning at the far end of the chart. Nevertheless, it's a great way of taking a look at what's going on. Now we can also check the field supply temperature. This is the temperature going out to or being delivered back from the well field. So we're starting down the middle of the winter at 40 degrees. We're essentially extracting heat from the ground at somewhere between 40 and 42.5 degrees. We're pulling that heat out, we're moving it up into the building. This is our source of heat in a ground source heat pump. Another interruption of power, and as the summer goes on and we're into the cooling season, we're pushing heat from the buildings back into the ground well field. And at this point, it's hitting the well field at about 50 degrees. Gives you an interesting idea about how the building is performing, what the temperatures are doing over a period of time. Notice there's some raggedness down here in the left corner, and this is when the compressors are being tuned up for the control algorithm. Let's go on and look at Concordia. Concordia is kind of interesting in that it is has one very large air conditioner. And if I drop down here, I can take a look at some energy alerts that came in. And here we had an unusual overnight energy usage. Our target was 25 kW, but in point of fact, we hit 35 kW. We also had a demand issue in which we hit 63, but we were targeting 57. So you can take advantage of this kind of data to better manage the demand in the building. You can do it manually or you can do it automatically. If we look at some more of the details at Concordia, here we have some real-time data that's coming in every few seconds. Actually, every 10 seconds it's updated. You can see when the building started. Looks like this is an air conditioning unit that's supplying the cafeteria. So it looks like since school is out, the cafeteria unit probably started around 2 o'clock, 1 o'clock or 2 o'clock, stayed on until about 5 and went off. That was his last night, yesterday. Not too bad, but it's an understanding that we may have an issue there. So let's flip over here and look at a chance to grow and get a better understanding. So for this building, which is a complete heat pump building, rooftop unit building, I built a tutorial that explains what's going on with the rooftops and their power is being consumed. This is a Sunday, and we're averaging something like 20 kW, and you can see from the jaggedness of the lines that we have a lot of compressors that are going on and off. Let's scroll down and see the temperature. But the temperature was very cold, 15 degrees up to about 27.5 degrees. So why were compressors going on and off? Now, the magnitude of these fans may mean, the magnitude of the changes may indicate that it's nothing more than the fans themselves that are cycling. But several of them have to cycle at the right time in order to get this kind of an approach. Some of the kW swings are significant, approaching 10 kW when the motors themselves are probably half a kW to 1 kW. Here's some more indication of what's been going on in the building. We could tell when the building started up right about 7:30 and it took off at 70 kW. We also know it's reactive power because we're looking at the motors themselves, their contribution to the power usage. Here's a good look at the day on a whole for that particular time we're analyzing the building information. For something like A Chance to Grow, it's also interesting that, or any of the buildings for that matter, you can look at the entire period of time and recognize what's been going on with the power in the building. We had a very high spike here on this particular day, much higher than it should have been. That's the kind of spike that you can get charged significantly extra for if you don't have some management control, some method of flattening it out. We had some other low spikes. Generally, they're related to the outside air temperature. I don't happen to show that on this particular chart, but we can superimpose multiple values on it. If we look at what's happened at River's Edge, which is a smaller building, they experience some spikes coming in about once an hour. And everybody checked. We're still not quite sure what's causing the spike. It's an old industrial factory, so there's a number of things that could be contributing to it. The reactive values indicate that indeed it was a motor. It is a motor, about 3 horsepower motor. This is another way to take a look at what's happening with the power consumption in the building and tracking it back to specific devices. Here is Northland Community Schools. We're going to look at a rather sharp spike that took place. This peak took place at 10:50 a.m., lasted about 15 minutes. All 3 phases were on, so it was probably a 3-phase motor. And the spike is significant. It's about a 50 horsepower motor equivalent. We jumped down to a report we prepared, and here I pulled out some of the technical details looking at the different peaks for the various phases. So I actually looked at the details to find out what was happening in the building, and we were eventually able to track it down. So this is an overview of how you can take advantage of the building energy consumption and how the data coming in from utility submetering can be used as a practical matter. Thank you.